Hey everyone, this is another, leak code problem, interview, question, coding, whatever. I guess it's reconstructing a sequence, supposed to be a hard problem. Given a sequence, original sequence, and an array of sequences, write a method to find if original sequence can be uniquely reconstructed from the array of sequences. Unique reconstruction means that if we need to find backtracking. Unique reconstruction means that if we need to find if original sequence is the only sequence such that all sequences in the array are subsequences of it. Going into example one, our sequences here 1, 2, 2, 3, and 3, 4. So it has to be 1 has to be before 2, 2 before 3, 3 before 4. And so the only thing we can do is 1, 2, 3, 4. So going down here, 1, 2, 2, 3, 2, 4. Since we go from 1 to 2 and there are no rules governing 3 and 4, like the ordering between that, we are able to create that. Therefore, it is false because we are able to create one of the two, either or. We can create either or, and it would still be valid. And 3, 1, 4, 2, 5, basically the subsequence of 3, 1, 5, 1, 4, 2, 5. Basically, since there are no rules in here regarding 4 and 2, we can just substitute the 3, 1, 4, 2, 5, and then we would make that. So there's only one because that is the original sequence that we have. So we're going to be solving this with topological sort. So I'll write out basically what we're doing. So we have an edge case here, which is if the length of original sequence is less than or equal to 0, return false, because there's nothing that we can it can't be unique or not unique, because there is nothing to do for like the sequence, if that makes sense. We're going to not original, initialize the initialize, what is it, the objects, in degrees and out degrees for top sort. We're going to populate in degrees and out degrees with information from sequences, and then we're going to create a queue and populate with items that have 0 in degrees. And so for a while queue, while the queue has items in it, check to see if that item is the only item in the queue, otherwise move forward. I know I didn't really explain these, but for all the topological sort problems, we've already done this. So I hope this makes sense. In degrees and out degrees, for top sort, we populate it with information from sequences and we create a queue. And then so to explain this part is, while the queue has items in it, or item, and I guess items, check to see if it's the only item in the queue, otherwise return false. So the reason why is, with this example, right, if we were to create everything and then we get here, we do 1, 2, and then after doing 2, we're able to add 3 and 4 into our queue. So, whoops, that's the wrong example. When we do 1 and 2, so after this, we can add 3 and 4 into our queue, which allows us to have a potential of 1, 2, 3, 4, or 1, 2, 4, 3, which means that that cannot be the only solution. Also need to check if the current item number in the queue check to see if that number, I guess this should be numbers, numbers that have 0 in degrees, only number in the queue. If the current number in the queue belongs in the next spot in our result. If not, return false. So basically, for us, because our in degrees is going to be a map, it's possible that we add 4 before 3. So let's just say even if we didn't pass this, when we get 4 here, we look at it, and so 3 doesn't equal to 4, so we know that there's a different solution that we can create. Therefore, we can return false and exit out. Otherwise, perform normal top sort activities, which consist of adding the number to the result, looking through out degrees to see if this current number frees up any other numbers, not frees up, reduces the in degrees for the other numbers to 0, to which means we can add that number over to our queue. And then actually no, I don't need to do all the spaces, because when I type it, it'll just go through. And so we're going to return, I'll just type out the solution here as well, original sequence is equal to the length of a result, because if the length is different, we have a different sequence. Than the original. Yeah, so that's what we're going to do. Yeah, so since I already mentioned that we're going to be using a queue, gonna import dq right now. I'm just gonna return length of original sequence is equal to the length of result. So yeah, so I guess I should also just do result is equal to a list here, and then we're gonna have in degrees is equal to a map, out degrees is equal to a map. So before I actually populate the information, what I'm going to do is for sequence in sequences, for number in sequence, we're going to do in degrees number is equal to 0, and out degrees for number is equal to a list. So basically this populates everything. While you can also do something like a default dict of an integer and also default dict of a list. You could probably do something like that, but not sure how exactly some interviewers may see that, because you're using something, I mean, at the same time, it's in the same collection as DQ, and it's not like I'm going to implement DQ myself. So you can do either or. I think I've kind of just gotten used to doing in degrees and out degrees like this and populating the information myself. But yeah, you can also feel free to use the default dict implementation as well. So now that we need to populate in degrees and out degrees, what we're going to do is for sequence in sequences again, for number in, actually no, not for number, because we actually need the index here, for I in range of the length of sequence -1. The reason why we're doing -1 is because we do not want to, because we're going to be comparing 2 at a time, and since we're comparing 2 at a time, is either we start at 1 and end at the last index, or we start at 0 and end 1 before. So whichever one works, up to you. So I'm just going to call it first and second. It's just first and second numbers that we're looking at. So it's going to be sequence I and sequence I plus 1, right? And so here we're going to do in degrees for second plus equals 1, out degrees for first dot append second. So basically this just means for the first, so we're going to look at this sequence, right? Actually, we'll look at this sequence just because there's more numbers. We'll look at this because this one's longer. So we have first and second, so 1 and 4, 1 and 4, and then so 1 has 1 out degree of 4, and 4 has 1 in degree because you have to wait for 1 to appear before 4. So 4 for first now becomes 4, second, 2 is now second. Same thing, so 2 now has plus 1 in degree because of 4, and then 4 has 1 out degree of 2. And the same thing here. 2 now has an out degree of 5. 5 has 1 increased in degree because of 2. So that's what we've done. We've populated in degrees and out degrees with the information that we do have. Actually, there's something I did forget. So here we want to do if in degrees, if the length of in degrees doesn't equal to the length of original sequence, then we do not have all of the rules necessary to create the original sequence. Right, so we just want to do if length of in degrees does not equal to the length of original sequence, then we return false. Yep, and then so now we need to create our queue, as mentioned here. Create our queue, and then for number in degrees, if in degrees number is equal to 0, q dot append number. Yep, so basically this just means if the in degrees for that certain number is 0, then we're able to add it into our queue, which means that we can start populating it into our sequence. So while queue literally just means there is an item or items, or in this case the numbers, right? Items in the queue, then we can keep going through the while loop. So we want to grab if the length of queue is greater than 1, whoops, not a lookup error, we want to return false. Like, because that means from this point in our solution, we're able to go more than one, more than one different paths. I will try to add this, hopefully, if I remember when I upload this. Basically, it sort of goes back to this problem where we have backtracking, right? And so these are the prerequisites and the tasks. So since the first index here, or index 0, we have 0 and 1, which means starting from there, we're able to path from 0 or 1 first. And then this problem just has us create that sequence, right? So since if we have more than one number here, then that means we know we can create more than one sequence, and it is not going to be unique. And for the second part, where we're going to check original sequence of the length of results does not equal to Q0. Okay, I did. Return false. So like I explained earlier, if we were to follow this example and like, let's just ignore the fact that we have this this length of Q check, but if we were to have 1, 2, and then since we're using in degrees as a map or a dictionary, we could potentially fetch 4 before 3, right? So if we look at 4, we know that it's different from original sequence because 4 doesn't belong in this spot. So we're able to return false out and break out of it. And so now this this part of the problem is just the same as all other topological sort stuff. So we're gonna pop left off the queue. We're gonna do result.append popped. So we can add it into our results because we need it here. And then we're going to do for number in out degrees popped in degrees number minus equals 1. If in degrees number equals 0, then we can q.append number. Yeah, there you go. And so that's just the regular topological sort behavior that we need to do in order to move on to the next iteration. And so looking at this, they believe this was true, this one's false, and this one's true as well. Let me just space this forward just so they're all lined up. Just to make sure we have true, false, true. So if we were to run this solution, run Python, true, false, true. So yeah, that is what we expect to see. And this is the solution for reconstructing a sequence. I hope that made sense. If not, please leave a comment. Let me know if like what doesn't make sense, I guess. And yeah, that'll be it for me. Thanks everyone.